So I changed frameworks again and came around full circle. This video is going to be about my path to optimization and what I'm doing client side to get the best results in this web MMORPG, which is an homage to EverQuest and will eventually become something else. I've had videos covering exactly what the vision is in the past. I'll kind of go over some updates with Requiem here in this video as well. But I mainly want to talk about client-side optimization for a web MMORPG, specifically with the BabylonJS framework. I'm going to go over a little bit of history of where I'm coming from and where I'm headed. So with EQ Requiem, this is a project I started a couple years ago when I wanted to recreate EverQuest in the browser, and there were some tools out there to convert existing EQ assets to something a little more web-friendly, GLTF, GLB. And I started out using the Lantern extractor, which people might be familiar with, and creating GLB assets. And I had a pipeline set up to try to optimize the best I could. And let me pop into that right now. This is still around the old website, eqrequiem.versal.app. This is about 2-3 years ago I started this. And for better or for worse, it's, you can log in, render. It's got nice lighting and everything. This was BabylonJS. When I started a couple of years ago. It's got some dynamic light culling with octrees and got some static zone points in there and looks pretty good. The thing is, when I tried to start implementing the entire stack and I hooked this up to the EQMU backend, and all of a sudden we had entities and we had movement and there's a lot going on, things started to chug. And all of a sudden I went from, my nice 120, 150 FPS down to about 30 or 40. So the bottleneck here was the number of meshes on the screen, number of materials on the screen for draw calls, and the animations that were going on. See, every entity had its own animation system, its own skeleton, in order to be able to provide distinct animations. You can have two different guard entities, but they need to be doing different things at any given time. You can't drive, one type of entity and say they're all walking, they're all doing this. So everything needs to be unique. That's a requirement. And everything needs to, scale well. And I try to come up with a lot of different calling strategies to really aggressively cut down on what's being rendered when, and I just couldn't do it. So I dropped the entire project and spent a couple of years building out tools, understanding the EQ format, and coming up with better ways to kind of be in control of the whole asset pipeline anyway. So I did that, and I started with EQ Requiem again. And first I prototyped in Unity and didn't have a great time there. Basically what I was working with at that time was GLTF, GLB assets, and the Unity web loader wasn't working with that because the third-party asset was assuming threads. Multi-threading doesn't really work in web, so I couldn't really run and load GLTF on the fly there. So that was kind of a non-starter. After that, I used Godot, and I stuck with it for a couple months, and it was working well up until the point where I started getting entities and animations again. And, I tried different kinds of optimization, different calling strategies, but I was running into the same issue, which is that there were just too many meshes in the scene, and they were all trying to animate, and there was no way to make these all distinct or, make these run concurrently or try to offload something to a different thread. Just wasn't possible. So what I eventually came back to, and I remember running into this the first time around, was BabylonJS's vertex animation textures, and I had tried using this the first time around. I just couldn't wrap my head around it, and didn't really have a plan forward, didn't really understand because I saw what it could do, but I knew my requirements, which were unique entities that had unique textures, had unique faces, had unique armor on, were moving uniquely in different parts of the zone, could possibly holding weapons, shields, that kind of thing. And I thought this was just all not possible. What vertex animation textures is a way to render animations like this on the GPU rather than using a skeletal animation system for vertex deforms. So I'm going to go into this right now. This is an existing system in BabylonJS, and other frameworks have this too. I think that there's plugins for Unity. I'm pretty sure you can do this in Godot as well. But I went back to BabylonJS because it's web native everything you're writing, you can look at it. There's no abstraction. There's no handle on a, C++ constructor, which just has the thin interface. Everything is very visible. And so far, I think, one of the biggest hurdles in any kind of web dev with scalability issues like this is like sometimes you just want things to just work right out of the box, and you get some really quick proof of concept coming up, and then you start hitting these walls where like, okay, wait, now I have 10, I have 20, I have 100, and it just doesn't work. And what do I do? Where do I go from here? And there's great documentation, BabylonJS, about optimization, but actually putting that into practice, there isn't this like, okay, silver bullet, I just turn on this one setting, or I just do this. You have to craft a kind of system specific to what you're doing in order to get the best results. So I'm going to go through all the different layers of optimization that I did to be able to render many, many entities on the screen at any given time. So what I ended up doing is using this vertex animation texture system, which gets rid of the skeleton entirely. And what it does is it bakes the animations into the skeleton, creates a texture, which is a real texture that you can look at. It doesn't really have any kind of meaning looking at it, but it does have meaning for the GPU. And I ended up getting some PRs into the BabylonJS source, which makes this a lot quicker, which means you can do it in runtime, just happens just like that. And also by cutting the memory in half by using a float 16 a half float instead of float 32, because you need one per type of entity in order to map up the skeleton to the animations. And this is what they end up looking like right here. So what we got over the X value is the types of transformations. We got scaling, transforms. There's let's see, position, scaling, and rotation. And on the y-axis, we have the keyframes. So I think there are 72 animations for this one right here. So this is a pretty big one right here. This is going to be, a couple megabytes. And I got some optimization for the size there, like I said, for the float 16. At the end of the day, it's a decent trade-off because we'll see how this scales up as well. For reference, skeletal animations in BabylonJS, in Unity, and Godot, you might be able to get away with about 50, 60, 70 entities running with unique animations. Once you hit about 100, you're going to start to see drops in frame rate to about 60, 50, 40 FPS, and it just kind of gets worse from there. So I'm going to take a look at our inspector, our performance we have going on here. We just got a couple meshes. We have very high absolute FPS. We don't have anything else going on in the scene. And we're just going to start to scale things up and see where this goes. So I'm going to share this playground here in the description as well. There's a lot going on into it right now. What it does is it bakes this vertex animation texture on the fly. It gets a texture from that with the float 16. And this is all stuff that's actually in the API right now. I got the Babylon PRs in, but I just have them here kind of for legacy reasons. But I'll link to the documentation as well. And what I'm doing here is I'm using mesh instances. So mesh instances all happen in one draw call. So it's not, number of meshes n turns into n draw calls. They're instances, so they all happen in one draw call on the CPU. And what they have is a custom shader material. Now, we need the shader material in order to supply the VAT, which happens in standard shader materials, but more specifically to pass in different parts of the textures right here, because the requirement being, there could be 20 humans, but they all, one has a plate breastplate, one has leather armor on. So the optimization I did here was to be able to look at all the different textures that could be on a human and create a texture array, basically an atlas, which is a 2D in this case, with uniform dimensions. And then I compressed that to a basis texture, which is kind of a generalized format for compressed textures. And I do have a proof of concept for actually loading the texture as compressed texture into the engine and GPU. That's kind of, it'll happen in the future a little bit, but what it turns into eventually is a raw texture 2D array, which you can't even visualize in here, but it's just this big array of all the different textures. So it's got like the chest texture, the glove texture, all these things. And by referencing a buffer. In this case, it's just a vertex or a vector wrapper. I can tell it, okay, you need to use index whatever based on how I'm looking it up through a map, which needs a big system to be able to do that, but it makes it possible as well. Now I want to start scaling things up and seeing how things run. So we got this small number of meshes right here. I want to start getting some more on the screen. So this is about where you'd start to choke in any other skeletal animation system. So we got a bunch of meshes on here. They're all happening in one draw call. And I'm still running at about a good 400 FPS right here. I'm going to spread these out a little bit as well. Okay, so we have about 104 characters right here. Now I'm running at about 500 FPS because I spread those out. They're not all, that's kind of the fragment limitation right there to be able to do, draw the triangles in one part of the frustum. Now I guess we'll see where this goes. Okay, I got 1,000 of these right here. At this point, this would be impossible with skeletal animation. Just wouldn't happen. So I'm still running at about 96 FPS, and so I've got requirements for my game, which is like, maybe 200 or something. So this is the point where I was like, okay, this works. I've proved this out. We can see we have different unique animations happening for every single one, different texture sets for every single one, all driving from one source. So if we go back to the materials right here, we only have one material. We only have one vertex animation texture, and each of them have a different buffer that's backing which texture am I using and how am I animating. So it'll be assigned to that, and then it can be controlled as kind of a handle through that, and that's how it works in the code in Requiem as well. This is just a small playground proof of concept, and this scales but doesn't scale forever because there's a couple different sets of wrappers in here as well. We can try 2,000. See where things go. I mean, realistically, this will never happen for other bottleneck reasons in a server. But, running 2,000 entities here, still at, 40 FPS. So pretty intense, pretty fun times. Yeah, I'm going to post description, links in the description for this playground and for the official. Here's some documentation that I had updated recently for optimized methods on vertex animation textures, and there's kind of an official, like, here's the small proof of concept to get started, kind of, to import your GLP, do the same thing. So enough of this. I want to get back into Requiem and where we stand there and kind of the optimizations I'm using there as well. So it's not just an empty scene with entities in Requiem. There's a lot going on. There's a UI, there's net connection, there's other geometry in the zone, there's physics. So I don't think I'll ever be able to scale up to 1,000 entities. So there's systems in here, like culling systems as well, I'm going to get into. This is on the latest right here. I've just done a UI upgrade recently. We'll check that out here in a second. And like I said, now we're on BabylonJS. But this is running and talking to my server that's hosted here at home. So this is reaching out to the internet. This is available. This is open and online. We have a Discord. If you're not part of that and you want to keep up with the updates, you can check that out there as well. So I forget where we stood last time I made a video, but these entities right here, they are real. They're backed by the server. They have movement. They have dead reckoning interpolation on the client side as well. So we might see some entities moving here. And in the meantime, like I said, I've done a UI overhaul, which is using the old classic stone UI, and got some kind of nice things coming up here. It's not complete yet, but this is the direction that I'm going to be taking for the UI. So when I open up my inspector here, we have a lot going on and a lot of unique entities that are all animating at the same time. And I'm still running at about 150 FPS here, which I would say is not too bad. So there are a lot of entities in this zone, probably 300 to 400 in the entire zone itself. But I'm only ever rendering some of them at any given time. And I'll cover some of the strategies that I'm using right here. I have a static grid system that uses calling in a couple different phases. Let me pull this up right here. Okay, so I have a zone grid that uses different cells in it, and what it does is keep tracks of the player. So the player's in the middle, and then cells that are neighboring. So neighboring diagonal, upper left, blah, 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 3 on each side. Basically turns into 3 cubed, which is 27 cells that it's looking at any given time, and every NPC movement might change into to a different bucket there as well. So it does queries based on that. Anything outside of the neighboring cells, instantly called, not even worth rendering, based on the size of the cells here. So that's the first part of the broad phase. I'll get into a debug mode here in a second. And the second part of that is going through a loop that happens every once in a while and checks the distance. And anything that is less than 200, we just want to automatically visualize. That could be right around the corner. We don't want to be doing GC churn for things that are all of a sudden in view and then out of view, in view, out of view. If they're within the radius, don't bother toggling. But if they're not, but they're still within neighboring cells, I'm doing some physics occlusion here using the Havoc engine. And that's using a collider against the zone geometry. And if it's behind, say, a wall or something that's further away, just turn it off. There's also frustum calling that goes on and everything in the engine, but I found this is a very nice way to, say, in a densely populated static dungeon for, like, the hole, for example, Black Burrow, something like that, that things behind walls don't need to be rendered if they're further away, even if they're in the neighboring cells. So this kind of like broad and more discrete phase turns into, okay, I can still run 200-something FPS, even if I'm around here. If there's an entity over here, there's no reason to render it right now because it's within my neighboring cells, but it's behind an actual piece of geometry based on the physics raycast. Yeah, I'll check out that debug view here as well. That's an interesting. Let's go ahead and get into the entity pool. Okay, so here are the cells that we're working with. Let me get some move speed. And whenever I cross bounds into another cell, it'll start using different calculations for what's visible and what's not. So you would see things start to kind of toggle on and off based on which cell that I'm in here. Right there, crossing a path into which cell. So this is pretty quick, pretty performant, and it works. This is one of the ways that I can keep FPS stable just by calling. Calling isn't everything, you still need to be able to render all this stuff at the same time. So the entire system that I was outlining in the playground there, that's kind of what I have here. I have an entity cache that's full of unique types of models, and then from there we can create kind of handles on each one and then drive the animations, drive the textures, drive the face, if they're holding something, blah, blah, blah. So it's a decent amount of code. Try to keep it as organized as possible, but everything is this mesh instance, even the player itself. And this is fun too. You can kind of visualize the physics of this as well. They've all got, I can probably push this guy off here. Let's see if I can do this. There he goes. Yeah, this isn't too performant visualizing the entire physics system, but this is going on behind the scene all the time, rendering every single frame. And Havoc has been pretty decent so far. That's going to kill my FPS forever, I'm pretty sure. And I'm still doing it okay. So the physics loop takes less than a millisecond every single frame. So doing okay right there. And those are dynamic physics elements there, so they move with the NPCs. That'll help them stay on the ground. And it's nice to have a little bit of collision here as well. This isn't the way it's supposed to end up, but it's fun to go bowling for NPCs right here. See, I'm just kind of, yeah, going for a little joyride. So that's one part of it. There's a lot of different other small layers of optimizations I do on the client. I'm going to be baking the React compiler in to do auto memoization. Other than that, I've been working React for like 10 years, so keeping things optimized, memoized, dependencies in line and everything, definitely number one. Don't want the UI thread to get in the way of that. Small things like, command handlers for semantic parsing of strings. I have a tree here, which is a data set, not a tree like a binary tree. And this is a little bit different specifically for semantic parsing of strings. So whenever I type L, it'll find the first thing, which in this case is location 2. And I got my commands wired up through, what do you call these? Descriptors here for these. So I got command speed, blah, 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 and it kind of finds the quickest way to do that. That's a really small optimization. That's not a hot path right there. And I'm going to stop this right here just by starting to talk about the net optimization. Let me pop in here for a second. And I'm going to pop back out. And I probably started talking about this in other videos. But this is a key part of being able to make this happen. I first started, I had this first idea like 3 years ago, and it's like, yeah, I can do this. You can use WebSockets. That's kind of what I was familiar with. And then it was brought to my attention that WebSockets not going to work. It has the head of line blocking issue, where if there's latency, if there's packet loss, all of a sudden things start to back up, and then there's big buffer on the back end. The front end's not getting updates, and you just get lag. So looked into alternatives and found web transport as the alternative, and that is exactly what I'm using. I'm probably going to get into this more in the next video where I talk about the backend optimizations. But this is the web transport mechanism right here, and it uses a control stream. It's over UDP, and this is, it's run on a different thread locally on an agent inside the browser, so I don't really have to worry about the overhead of getting that. I'm just taking back the buffers, translating them into packets, and then using a messaging protocol, using something called Captain PNP, which is kind of a derivative of protobuf, and I'll go into why in the next video. But just to be able to pass messages from the server to the client at a very fast rate, because in practice, whenever you're in the game and there's a lot of entities going on, there's a lot of net traffic that's going on with the game loop and things updating. And you try to batch this stuff, you try to make it as discrete as possible, but at the end of the day, you're going to be getting a lot of net traffic, and when the server is pushing that kind of stuff down on you, you need to react quickly and be able to show all the updates for every little thing. Basically, you can assume that it's syncing between the client and the server. But there's a lot more to come in the actual features being built out in Requiem. And yeah, it's on a good path. It took a little while to refactor from Godot to BabylonJS, but it feels so smooth and natural coding in BabylonJS now. The people there are really nice, and they all, want the same thing. No one's like elitist or, trying to control the whole, steer the ship. Everybody's open to everything, and it seems like a very fully fleshed out engine with a lot of things possible. So I'm happy I switched, and I can see this coming to fruition in BabylonJS to the end result. So I'm going to stop it there. If you have any questions, hop on the Discord. Definitely, I'm posting updates there almost every day, and hope to see you there, and hope you enjoyed this video. This was just a couple different layers of client-side optimization in the web. Okay, later.